Before starting video, please subscribe to our channel. A CNC computer numerical control machine is a sophisticated manufacturing tool that automates the control of machining tools like drills, lathes, mills, or routers using a computer. It operates by following a pre-programmed sequence of instructions in the form of G-code or M-code to shape, cut, or engrave materials such as metal, plastic, or wood. Here's an overview of how it works. Key components of a CNC machine. Controller, the brain of the CNC machine, where all instructions G-code or M-code are processed. Machine tools. These include tools like cutters, drills, and milling heads, which perform the material shaping tasks. Workpiece, the raw material to be machined. Drive system, motors and other mechanisms control the movement of the machine's axis X, Y, Z and the tool spindle. Feedback system, sensors ensure precise movements by sending real-time data back to the controller. How it works. Design phase. A CAD computer-aided design program is used to create the part's digital design. Programming. The design is translated into a CNC-compatible format using CAM computer-aided manufacturing software. This generates G-code or M-code, which includes instructions for tool paths, speed, feed rates, etc. Setup. The workpiece is secured on the machine's bed. The appropriate tools are loaded into the machine. The operator sets the machine's initial parameters 0 points, tool offsets. Execution. The machine reads the G-code and moves the tools along the defined paths. The material is machined with extreme precision based on the programmed instructions. Monitoring. Operators monitor the process to ensure quality and detect potential issues, though many modern CNC machines have sensors to handle this automatically. Advantages of CNC machines. Precision and accuracy achieves consistent, high-quality results. Automation reduces manual labor and operator error. Efficiency, faster production compared to traditional methods. Versatility, can work with various materials and create complex shapes. Applications of CNC machines. Automotive industry, manufacturing engine components and other precision parts. Aerospace, creating high-tolerance components for aircraft. Medical, producing implants, surgical tools, and prosthetics. Electronics, making circuit boards and enclosures. Woodworking, cutting and engraving decorative or functional parts. Thank you for watching video. For more informative videos, please subscribe to our channel.